But first, let's recall conducting ANOVA test in this example. You are asked to test the hypothesis that mu1 is equals to mu2 equals to mu3 equals to mu4. So this will be your null hypothesis. And class, do you still remember what is the alternative hypothesis? It's a constant, right? At least two of the means are not equal. And alpha is given as 0.05. For the tensile strength of paper by levels of food concentration, we have one factor here. That means we'll be using the one-way ANOVA. And 4 groups of 4 treatment levels. 6 observations, so I'm going to write it out here. 6 observations, 4 treatments. So our data points would be 6 multiplied by 4, which gives us 24. So the observations would be the tensile strength of paper. Let's move on to the test statistics. SST is given as, the formula is provided in your exam, so no worries there. Yij square minus y dot dot square over n. Okay class, I have some extra tips today, which is to use a special function in your calculator in order to get the value of yij square and y dot dot square. Okay, we are going to use the exact similar function in your calculator as when we calculated your standard deviation. So if you're using the Casio FX570MS like me, then you would go to mode, press twice, and then you select SD. Then you'll be keying in all of the data starting from 7 up to 20. So 7m plus 8m plus up to 20m plus. Alright? Once you are done, you would press Shift 1 and then you would select 1. When you select 1, it shows that it is the summation of x squared. So the summation of x squared would be the summation of each of the data values square, which is exactly what we want. Alright, so it gives us 6,625. Okay, then you press AC and then Shift 1 again. And now select 2. So when you select 2, it gives us the summation of x, or the summation of the data values. So you have there 383. So that is your y dot dot. So 383 is y dot dot. So you need to square this value divided by the number of data points, which is 24. And this gives us 512.9583. Okay. Unfortunately, the only way to get the values of the totals and averages, the yi dot and the y bar I dot, is by manually calculating the values. So when I add up 7 plus 8 up to 10, I get 60, and then 94, 102, 127. Okay, how do you find y bar 1 dot? You take 60 divided by the number of observations, which is 6. So you get 10. And again, 94 divided by 6 is 15.6667. 102 divided by 6 is 17. 127 divided by 6 is 21.1667. How do you get y bar dot dot? You take y dot dot divided by the number of data points, which is 383 divided by 24. And this gives us 15.9583. On to the next step, which is the sum of squares of the treatment. So SSA, the formula is the summation of y bar I dot square multiplied by 1 over n minus y dot dot square divided by n. So n would be 6. Y bar I dot, the values are already here. So we have 10 square plus 15.6667 square plus 17 square. Okay, minus y dot dot square, 383 square divided by data point 24. And this gives us 382.7917. So, what's the next step? Sum of squares of error. That's the easiest to calculate. SST minus SSA. And this gives us 130.1667. So next, in order to find F star, I'm going to rewrite all of the values here in your ANOVA table. SSA 382.7917, SSE 130.1667, SSD 512.9583. Now, if you add up this value with this value, you would get this value. Okay, so the values are already here, which I did not notice, but that's fine. And we simply take the one with the 4 decimals. Okay, so the degrees of freedom for the treatments would be k minus 1. K was 4, 4 minus 1 is 3. Degrees of freedom for error would be n minus k. N is 24. 24 minus 4 is 20. And the degrees of freedom of total would be 20 plus 3, which is 23. Or capital N minus 1. And how do you get the MSA? You take 382.7917 divided by 3. And you would get 127.5972. How do you get MSE? You take 130.1667 divided by 20. You would get 6.5083. So the value of F star would simply be this value divided by this value, MSA over MSE, which is 127.5972 divided by 6.5083. And we get 19.6052. Okay, then what's the next step? The rejection region. So the F distribution is skewed to the right. Alpha is 0.05. So you want to find the critical value here, which is F 0.05. Degrees of freedom would be K minus 1, which is 3 just now, comma 20. So I'm just going to show you again. The degrees of freedom, you simply select this one and this one. So 3, 20. Let's have a look at the F distribution table. Okay, the degrees of freedom is 3, 20. Alpha is 0.05. And so the critical point would be 3.10. This is 3.10. So now I'm going to compare the test statistic here with the critical value. Definitely falls in the rejection region. And now we can make a conclusion. F star falls in the rejection region. So we reject H null. Let's see what happens when we reject the null hypothesis. Okay, so this is the whole question. So there's no definite question here. They simply ask you to test the hypothesis, right? And now you are actually rejecting the null hypothesis. So this has been rejected. And we accept the alternative. At least two of the means are not equal. So you could rewrite it. You could rewrite the conclusion as at least two of the mean of the observations, right? Two of the mean tensile strength of paper are not equal or are different. So you can write that. Or the levels of wood concentration significantly affects the mean tensile strength of paper. So why do I say that wood concentration affects the mean tensile strength of paper? Because if the wood concentration has no effect, then the mean would be the same. So it doesn't matter if the wood concentration is 5% or 10% or 15% or 20%. The mean for 5% is equals to the mean for 10% is equals to the mean for 15%. This equals the mean for 20%. But we have rejected the null hypothesis, which means this wood concentration has an effect. So I'm going to show you how to write the conclusion in two ways, and you can choose either way in your exam or assignment. But usually we answer the question, right? Like yesterday we answered the question. Now I'm just going to show you if there's no exact question on whether the wood concentration has any effect on the tensile strength. So the first way to write your conclusion would be at least two of the mean of what? Right? These are the observations, right? So I'm just jotting this down to make it easy for you. So you always find the observations, not the factor, alright? So the mean tensile strength of paper are different. So this is exactly as the alternative hypothesis. At least two of the means are different, or at least two of the means are not equal, right? It's just that I added this sentence here. And this is the observation. Okay, so this is pretty simple to write. You simply copy down the alternative, but after the word mean, you add in the observation. Okay, the second way to write your conclusion would be whether the factor has an effect on the observation. So the factor is the wood concentration. Maybe I just jot down the formula. If we reject the null hypothesis, then there is an effect of the factor affects the observation. Okay, so this is the formula to write it down. And now I'm just going to write down the whole sentence. What is the factor? The levels of wood concentration. You can write significantly affects, or you don't have to write it. Okay, maybe I just don't write it. Affects the observation, right? So what is the observation again? The mean tensile strength of paper. Mean tensile strength of paper. Okay, I hope I made it easy for you to write the conclusion in any case. Okay, on to something new that I would like to discuss with you. Now, you could be asked to find the confidence interval of the mean of any treatment, and this is the formula. So the confidence interval for any treatment is simply y bar I dot plus minus T alpha over 2 square root of MSE over N. Let's take a look at an example so that we could solve this. Okay, calculate a 95% confidence interval. So we have a 95% confidence interval for 20% wood concentration. So the 20% would be mu 4. This is mu 1, this is mu 2, mu 3, mu 4. Oops, mu 4. Okay, clear? And the formula is y bar I dot, right? So because this is mu 4, that I'm going to write it as 4 dot. Remember, plus minus T alpha over 2. So what is your alpha? 5%. Over 2 would be 0.025, comma. K is the treatment level, which is 4, multiplied by N minus 1. N is the number of observation. So 6 minus 1 is 5. Multiplied by the square root of MSE over N. So the MSE was 6.5083. 6.5083 over N, which is the number of observations. And what is y bar 4 dot here? 21.1667. So we need to use the T distribution table. T 0.025, comma, 5 times 4 is 20. Degrees of freedom is 20. Degrees of freedom 20, t 0.025. So the t value is 2.086. And this could easily be calculated as 18.9941, 23.3393. And finally, you might be asked to construct a confidence interval for the difference in any two treatment means. And this is the formula. So let's say you're asked to construct a confidence interval for the difference between mu1 and mu2. So your I here would be 1 and j would be 2. I would be 1, j would be 2. So the formula is y bar I dot minus y bar j dot, and then plus minus t square root of 2 MSE over n. Let's try out an example. Let's calculate a 95% confidence interval on the difference in means mu3 minus mu2. Remember which is mu3? This one here, mu2. Alright. So these are the average. So the formula is y bar 3 dot minus y bar 2 dot plus minus t alpha over 2, so 0.025. It is n, capital N minus k. Capital N was 24 minus k is 4, you get 20. Alright, this one comes from capital N minus k, which is 24 minus 4. Square root of 2 MSE, our MSE was 6.5083 divided by n, which is 6. So this value is similar to the one we previously got. So I'm just going to rewrite that. Also, the actual value for y bar 2 dot is 15.6667. We have calculated this just now. So we have here 17 minus 15.6667 plus minus what we got just now was 2.086 square root of 2 multiplied by 6.5083 divided by 6, and using your calculator it's easy to get the final answer, negative 1.7392, 4.4058. So if you're asked to interpret the confidence interval, you would say that, maybe I just write it down for you once. We are 95% confident that the difference in means mu3 minus mu2. So I'm just going to write it as mu3 minus mu2 is between negative 1.7392, 4.4058. As easy as this, because we have a strong foundation of statistics, right? So everything comes from one mean. And then you could do hypothesis and confidence interval for 2 means and more than 2 means. That's why your basic must be very strong. Okay, class, what have we learned today then? Constructing confidence interval for mu I. What's the formula? Y bar I dot plus minus alpha over 2 k times n minus 1 square root of MSE over n. We also learn how to find the confidence interval for mu I minus mu j. What's the formula? Y bar I dot minus y bar j dot plus minus t alpha over 2 n minus k square root of 2 MSE over n.